Hello, everyone. Welcome to the session about TouchDevelop and TypeScript. My name is Michał Moskal. I work at Microsoft Research, just across the street here in Redmond. And I'm going to tell you about today about a bit about TouchDevelop, which is an IDE for the web, and how we made it. So, well, this is how my first computer looked like, right? I mean, probably for some of you it seems familiar, right? Kind of boots up, and it prompts you. You get a basic prompt, right? It wants to be programmed. It wants you to program it. And this is actually how a lot of people learned how to program, right? They got those 8-bit computers, and they kind of tinkered with them. They write little games and so forth, right? Now, nowadays things are a bit different. The first computers that people get are actually smartphones. They are not those 8-bit computers with keyboards. They have no keyboards. On the other hand, they are quite a bit more powerful than those 8-bit computers, right? They have CPUs that are 1,000 times as fast, lots of memory, high-resolution displays, everything. So they have those amazing devices, but you cannot really program them. It's not that easy, right? And usually people say, I mean, you cannot really program it because it doesn't have a keyboard. Well, so at Microsoft Research, we try to see what's possible. We try to explore possibilities. And today, I came here with two kinds of hats. I have a researcher hat and a developer hat. So right now, I'm going to put my researcher hat on and tell you a bit about, motivation of why we did TouchDevelop and what it is first. So the questions that we wanted to explore, right? Can you actually program on those little things, right? Can you actually program, with a single finger? Well, yes, we can. So this is a project that we started maybe 2 years ago, around 2 years ago. And we built this Windows Phone 7 app that lets you program the phone on the phone itself, right? The basic editing experience consists of 2 modes of operation. In one mode, you edit the tree structure of the program. You edit statements, you add if statements, you have the block structure, and so forth. And in the other mode, you zoom in into the expression level. And there you actually have those like little buttons here that show the IntelliSense, right? And then you program. You program at the token level. And there is actually, for example, a lot of smarts that went into making sure that these suggestions that you get there are relevant, into kind of figuring out how do you actually edit the tree structure of the program on such a small screen and so forth. But the basic idea, is to really bring this joy of programming those 8-bit computers to the smartphone age. So I'm going to show you like a little quick demo. Okay. So I'm just going to start it up. It's an app that you can actually download for a Windows Phone if you have one. So I'm going to load up this game that one of our users wrote. And first I'm going to just play it. Probably know that game. You've seen it. This is the same game that was there in the 1997 on those Nokia phones. The difference between 1997 and now is that in 1997 you could play the game on your phone. Now you can actually write it on your phone. And when you look here, so this is, for example, the main function of that program, right? So this is like two screens of code, and there is like 10 functions in here. It's not that complicated on a grand scale of things, right, when you talk about apps and so forth. But as far as, entering it on a phone with a single finger, it is quite involved. But because of all the IntelliSense and so forth, so I can just go here and edit it. If I delete that, right here, I get those IntelliSense suggestions at the bottom and so forth. So because we actually provide you with that environment, it was possible for that user to write that. Okay. So as for the phone app, it actually works, right? We had 200,000 downloads in the Windows Phone 7 marketplace. There is a full social experience built into the app. So you can share the scripts with others. Once you write your script, you can publish it with a single button click. It's really easy. You can comment on scripts. You have your user account and everything like that. There is about 10,000 scripts that were published. So those are, for example, the screenshots for a couple of scripts that our users wrote. Here we picked really the most colorful, so they tend to be games. But for example, here in the corner, you can see that there is like a plotting thing. So we have like a built-in plotting thing. So you can, and because of that, it's actually very useful for teaching. It's much more engaging for students to sort the songs that they have on their device or play a little game than say sort numbers. Right? It's much more engaging to actually program the phone, because there you can actually interact with the content that you have on your phone. So, well, what's next? While the phone is probably the first computer that people nowadays have, this is the second computer that they're going to have. It's going to be also a touch device. It's going to be a tablet device like this one. And so far, we have been limiting ourselves in scope, to one form factor and one platform. And we wanted to have more reach. We wanted to go to more screens, have more diversity there. And this was actually going to bring, so the idea here is that you wanted to research how does this thing scale to a bigger screen? Does the touch actually bring some interesting insights in how do you program those things, and so forth. So, well, we decided to make it into a web app. And this is actually how it looked like, and I'm going to give you a demo at the end of the talk after I told you how we did it. So, well, we decided to make it a web app, and now I can put on my developer hat on. So, at Microsoft Research, right, we do both the research part and then the prototyping like this one. So that's my developer hat. So what was that what is that web app? Well, there is like this HTML5 component, there is some JavaScript, and then there is some cloud component. Okay, fine. Now, what do we have? Well, we have 100,000 lines of C# for the cloud that powers all that social experience and so forth, the script publishing and so forth. And this is actually good. This can stay. I mean, we need to change the communication protocols a bit and so forth, but this can pretty much stay. Now, on the client side, we have even more code in C# and a bunch of XAML. And how are we going to run that thing on in a web browser? Well, we are not. We need to rewrite it. So, and I was actually the one who started that rewrite. So TouchDevelop, there is a team of like 5 people working on it. I was the one starting that rewrite because I was the one working on that editor and the language part. And this is kind of the core of the experience, right? So this is where you start, right? You see how does the editor scale to a bigger screen. And then on top of that, you add all that social things and so forth. Well, I needed to learn about all those technologies. And the XAML part is really going to be replaced pretty much by some HTML5 and CSS3, right? So who did some web programming, say, in the last 2 years? Okay, some people, but minority. So actually, my experience was, the last time I did any web programming was like, I don't know, 7 years ago or something. So things have changed. Actually, in the last few years, it is actually much better than it was. So in particular, well, one nice thing about building web apps is that you have very short response time. Edit compile cycle is really short. You just go, change the web page, reload the web page, and it's there. No need for deployment and so forth. Just reload the page, it's there. It's also the case that the modern browsers provide you with all sorts of tools that let you tinker with that let you change the HTML on the fly, look at the DOM tree, and so forth. All actually modern browsers do that. So this actually makes it way easier than it was a couple years ago. it also has gotten very popular, which means that if you don't know how to do it, well, probably how to do something like, center a div in a different div or whatever. Well, probably someone did that before. You just put the query into the Bing, you find the solution. So you kind of really harness the crowdsourced answers. The HTML5 in the modern browsers, it's really highly optimized. The rendering process is really highly optimized. It's really fast. If you just create a giant HTML tree, dump it on the browser, ask it to render it, it will do it quite fast. If you, on top of that, add some CSS tree animations, those are all hardware accelerated. This all really looks really good nowadays. And this actually has changed maybe in the last year. This actually has gotten much better. It's also quite simple in some sense. You don't really do all those controls and so forth. If you want a list viewer, you just add a div and then add a bunch of div in it. You set that outer div to scroll, and that's it. That has advantages and disadvantages. There isn't so much abstraction in there, but it's actually usually easier to get started. And the final thing, it is resilient. It doesn't crash on errors. If you have an error in HTML5, the HTML standard actually specifies what should happen when that how should the errors be rendered. They actually have error recovery in the standard. So it just looks a bit off. You go and fix it. OK. So yeah, they might have worked a bit more on the logo, I guess. But anyway. So now to that JavaScript part. It actually shares the first two characteristics with HTML5. It's also immediate. You refresh the page, it's there. It's also very popular, just being around for answers. It's also quite fast nowadays. Some programs are actually even claimed to run faster than native code. That's not the usual experience, but usually it is fast enough for most applications with modern JITs in the modern browsers. Well, while the language itself in JavaScript is not that complicated, the language itself is quite simple. If you want to actually program in it, there is like literally 20 different ways of doing object-oriented programming in JavaScript. And also, it is a dynamically type language, which means that if you make a typo somewhere, it will just not find the property. And if you try to call it, it will just crash. So especially those two final things, right? They may be fine if you are just writing like very small applications, right? Very small applications yourself. But if you have a team working on a bigger app, they are really, really problematic. And probably like yourself, I've been using strongly typed languages in the past, right? I've mostly like ML, F# and so forth, but also C# in TouchDevelop and so forth. And all that dynamic typing thing that just didn't, sit so well with me. So, well, now about TypeScript a bit. So who's been to Understock about TypeScript? Half of the room. So I'm just going to quickly tell you what TypeScript is so that you get some idea. Well, TypeScript is a superset of JavaScript. So any JavaScript program is a TypeScript program. And it adds types annotations to JavaScript, right? So it adds a type system. It has a syntax for defining classes, interfaces, and modules. And because of the type system, it enables much better tool support. So you can have IntelliSense, say in Visual Studio or in a web editor. You can have refactorings and so forth. And this isn't really about the implementation of a particular language service. It's really about the language, right? It's the language that, the static type system in the language that lets you even do that. You can try to do IntelliSense in JavaScript, but this is not going to work all the time. And finally, it's actually available right now in developer preview, right? So it's not a final product yet, but it's in developer preview. And the high order bit here really is that TypeScript is an easier way for people used to statically type languages like C# to start being productive in this JavaScript world. So TypeScript is a superset of JavaScript. And that means that you can essentially, if you don't like this type system in some place, you can just annotate type with any. You can just say that this is any type, and then everything goes. This is like dynamic, I guess, in C#. And, well, of course, you would wonder why would you do that. Well, usually you would do that because you, for example, take some, you find some solution for some problem on the web, just paste it in, and then you want that thing to work. You don't really, care all that much how it works. So then you can just do that. You can do all the crazy JavaScript things that people do. The eval is still there, right? You can just pass a string, it will evaluate it. The reflection is super easy. And actually, when you're writing things like TouchDevelop, which is really a compiler, right? It has this embedded language, and we just compile it and then run it. It's really great, right? You just generate a bunch of JavaScript, pass it to eval, and then it actually will use all that goodies in the JIT to run fast. And you can use existing JavaScript libraries. And if you actually have type annotations for them, you will get type checking for them, and you will get IntelliSense. And the type annotations are provided with TypeScript for the DOM, so for the different operations on the HTML trees, for WinRT and jQuery. And there is more, I guess, that can be sourced from the community. You can also write yourself. Now, let me show you a bit of code. So this is like a very short fragment of a class that represents a sprite on a board in TouchDevelop, in C# and in TypeScript. C# is on the left, TypeScript is on the right, as you can see. So it looks quite similar. The syntax is slightly different, but the structure is quite similar, right? So instead of namespaces, you have modules. Modules are actually first-class values, unlike namespaces in C#. Instead of public, you say export on classes. You say extend instead of a colon. And there are like tiny differences like that, but the top-level structure seems very similar. Then the type annotations in TypeScript are written on the right-hand side after the colon. The reason for that is that they are optional, so you can skip them. So if you put them in front, then it will be ambiguous if you skip them. That's why they are after. And so this is a function signature of method that computes forces that work that affect the sprite, right? So it takes a vector 4 and it returns a vector 2, and here you write it slightly differently. But the top-level structure is quite similar. Also, in JavaScript, you very often use arrays, where in C# you would use lists or arrays or a couple other things. Now, okay. And this is the part of the body of that method that computes the forces. So here it is maybe slightly more different. So for example, instead of for each loop, you would use the for each function and then pass a function to it so that it iterates over the elements of the array. The for loop is pretty much the same, except that in TypeScript, the this dot isn't optional. You actually have to always say it. There is also no let me see. There is also no operator overloading in TypeScript. So here you can see plus equals on that force, which is a vector. And here you actually need to use a method. But again, the structure is quite similar, but it was always like that with JavaScript, right? So really what TypeScript does, it provides you with that top-level structure that is similar to C#. Now, this translation from C# to TypeScript, it is actually really what happened for this sprite class and the board, which has this physics engine, which is quite involved. But this isn't really what we did for the entire app, right? Most of the app was actually just written from scratch. And if you really want to just take your C# code and make it run in JavaScript, there is something called Script Sharp that you may consider instead. So this is really if you are writing a new app. Or want to have like a full web experience. Okay, so let me now show you some code. So this is a really simple example. that defines a class. Okay, first thing, I define a method to display something on the screen. Just don't worry about that guy. And then I define a class greeter. It has a field greeting of type string. It's actually public by default. And I define a constructor for that class. So again, the syntax is slightly different, but similar to C#. Now here on the right-hand side, you can see how it translates to JavaScript, right? So there is a function defined. There are functions in that function. And for example, this is how a method is defined. And here, but of course, what you have to write is the thing on the left-hand side, right? The JavaScript translation is here only for illustrative purposes. OK, so let's just run it. Just run it. It says hello build, right? Because I passed the string build to it, right? And it added it to the constructor, right? It saved it in here, and so forth. You can actually make that a bit shorter. You can just say that the message is actually supposed to be a proper, that the greeting, you need to call that greeting. And then you don't need that. And it actually has the same effect. So you don't have to do these assignments in there. So this is like a nice little syntactic sugar. So very simple example. So let's just move on. Now, this is essentially the same example. So what I'm going to do now, I told you that TypeScript is a superset of JavaScript, right? So I can just actually take the JavaScript from the right-hand side, this bit here, and I'm going to just stick it here. Right? So what I'm doing here is taking the prototype of that greeter class, so really taking the definition of that class and overriding some method. Right? And say, instead of saying hello, I make it do something else. I make it say dzień dobry, which is hello in Polish. And then greeter. Now the cool thing about that is that you actually get IntelliSense, right? The TypeScript compiler is written in TypeScript itself. That's why it can be hosted in our web browser. And because of the type system, you get IntelliSense here. Right? So I have greeter, greet, and then I pass something. Now if I run it, it says hello build and then dzień dobry build. So the first call to the to the greet method invoked the original method. Then I have overridden it dynamically, and then invoke it again, and now it invokes the overridden method. So this is something that people do in JavaScript, right? They sometimes go to existing classes and change their behavior. They override existing methods. Now, this isn't usually what you would do, but some people do that, especially in libraries. And if you want to use those libraries in TypeScript, that's why TypeScript also has to support that. And the interesting thing here is that, let's say, I messed up the type here, right? Instead of, say, passing one argument, I pass two. TypeScript is going to complain. It doesn't like that, right? It knows that the type of the greet method should take one argument. Moreover, if I just go here and say s dot, it actually knows that it is a string. It shows me all the methods on a string. So it is actually taking this. This JavaScript overriding method and trying to put static type on it. Okay. Now, the other variation on that is that you can actually also extend existing classes, and this is also sometimes what libraries in TypeScript in JavaScript do. They extend existing classes. So, for example, the type of document body, if I h over it, it says HTML element. So the type of the body is HTML element, and I can actually go take the interface HTML element and extend it with a method of my choosing, which is in that case I just happen to call it unlink, and then it's going to include everything that it has in the library for HTML element, all the usual methods, and then that additional method that I have here. And I'm kind of doing that in a completely separate file. So this is providing the type signature for it. But then what I can do, I can actually provide an implementation, right? So, well, what it is supposed to do, it is supposed to take a node in HTML3 and remove it from the tree. there is no such method, so this one does it, because you always need to take it from the parent. So it's not complaining about that, and if I, again, if I try to do something funky here, it's going to complain, right? It knows the type. And the other reason to extend existing interface is, maybe it's missing in, maybe it came from external library, and then you want to add it. Okay. So now a bit about modules. So modules are somewhat like static classes in C#. So classes that don't have any instances. So you can define functions in modules. You can export them or not, right? So here there is the function fetch and function called something else in that module called cloud1. And I can add another function, right? That doesn't do anything. And now if I go to cloud1, it's actually going to show me the function that were exported, right? So that's all fine. Now, the next thing that I'm doing here is defining an interface with a method fetch, which has the same signature as the method in the interface, but it does not define something else. So then, actually, the interesting thing about modules in TypeScript is that they're actually first-class values. They are so in C#, classes are not values. And in TypeScript, they're actually values. So you can take the value of the module, cloud1, and assign it to a variable. And by the way, give it a type cloud interface 1. So what this is going to do now, right, if I go to the cloud now, it only shows me the method fetch. So I limited the set of methods that are statically visible outside. So this is essentially applying the concept of interfaces not only to classes, but also to modules. So, and if I say try to call the something else method on it, I get an error. Right? It shows me, it tells me the property something else does not exist on that value. However, I can just go ahead, and actually when you look at the right-hand side here, it is, even though it gives an error for it, is still compiling it. So this is a design choice in TypeScript that they actually always try to compile your program, because again, you might maybe just copy-paste, you maybe just kind of trying to compile some JavaScript library, and well, you know it works, you are not really interested in developing it, but you still want it to compile with your project. However, if you don't like the error, you can always cast to any. You can always cast to the dynamic type and bypass the entire type checker. And then, well, the JavaScript generated for that is essentially the same, but there is no error message. Now, because of that casting to any, TypeScript doesn't really give you any guarantees about the code that you are writing. It's not actually, it's not like C# that is only going to fail on casts and not say, for example, on invoking the method. And actually, this is, again, if you want JavaScript compatibility, this is the only possible choice. And I'm actually going to come back to that a bit later. Now, finally, if you want, because those modules are really values, you can, again, go ahead and override existing methods by just assigning to the field of the module. So here, I'm just overriding this fetch method with something else. OK, now a little. So Anders was showing that, but he wasn't actually showing that thing down below. But let me go through both of them then. So what is this method supposed to do? Well, this one here. Right? It takes the array of 2 elements, 2011, 2012, 2 numbers. And for every value in that array, it's going to try to print the greeting, for which we are going to pass the build string and the number, right? So if I run it, I would expect to see build 2011 and build 2012. No luck. I get undefined 2011, undefined 2012. Well, the reason for that is the way JavaScript treats the this pointer. Here, you would expect so if I actually have a this pointer here, it shows me, it even shows me the type. The type of the this pointer is greeter. If I go inside here, the type of the this pointer is any. So the this pointer has strange semantics in JavaScript. I'm not going to really go into the details of that. But well, let me show you how to fix it. The typical JavaScript way of fixing that is to put it in a local variable. Then it has type greater. And then we can run it. And then it works fine. But of course, you shouldn't be writing something like that. Right? So this is just silly. So what you can do instead is you can use a different function syntax, which is actually which is probably going to be more familiar to you. So if you use this function syntax for defining lambda expressions as opposed to those JavaScript functions, the TypeScript compiler actually does the thing for you, right? It introduces variable underscore this, captures it outside, and then uses that one inside, right? So the message here is essentially, unless you are overriding existing methods in classes and so forth, just use this arrow syntax, don't use this function syntax for defining your functions. Now, there is another interesting thing that also has to do with passing the this pointers around, which is called that in JavaScript, the eta conversion rule doesn't work. So we have that function here. It's greeter.greet, and then it works, right? Now, if I do that, g gets greeter.greet, and then call g. Would expect that thing to do the same thing, right? I just took one expression, put it in a variable, and then invoked that. I mean, everything typechecks, everything seems fine. But when I run it, it doesn't work again. So that's the second one, right? Undefined here. So the reason for that is because now this call to greeter is going to pass this being, undefined. Being null, and that's why the global object. That's why it doesn't work. Now, the typical reason you would actually be doing something like that is because, for example, this is an event handler, right? And usually you save it in a whatever. You save it in a field or something, but the rule is the same. Well, the way to fix it is just do this eta conversion, essentially add a function expression around it, and then it works. It had set build everywhere. So here really the takeaway message is, yeah? Oh, sorry about that. It just has the function here. So it really, this is going to capture the this pointer for you. Normally the this pointer is not captured, and that's why it didn't work. Oh, actually the greeter pointer, really, which is passed as this to the greet method. Okay. Now, another thing that is a bit peculiar about JavaScript and by extension TypeScript. Now, by the way, in that previous example and actually in this one as well, you may wonder why doesn't TypeScript fix that, right? Why do we still have this function that kind of has this weird this behavior and so forth? Well, again, if you want to use JavaScript libraries, you cannot fix that because this is going to change the semantics of the language and the library is not going to work. So the only thing that they can do is to essentially extend the language and provide you with a different syntax to do the same thing. And here again, we have a interesting peculiarity of JavaScript. So here I'm going through the elements of an array. It's an array of 3 fruits, pears, oranges, and bananas. And I'm creating a variable for each one. And then I'm adding to the list of callbacks a functional expression that I'm going to call later, right? Again, normally the reason you would do that is because you are sticking in some object somewhere so that it is called later. For example, an event click handler on a button or something like that. So we're essentially collecting those expressions. So echo of pears, oranges, and bananas. And then later here, I'm just going to call them one by one, right? So really, we would expect that thing to print pears, oranges, and bananas. No luck. It prints 3 times bananas. Well, the reason for that is we would think that because we define this fruit variable in a block scope, each iteration of the loop is going to get its own fruit variable. But this is not the case. That would be then captured by, the fruit variable would be then captured by this lambda expression. This is not the case. Blocks in JavaScript do not introduce a scope. The variables actually escape the blocks, and there is just one instance per function. So there is just one fruit, and this happens to be the last one through which we went, right? That's why we get bananas 3 times. Now, one way to fix that is to introduce anonymous function here and do things like that, but this isn't really how you are meant to do those things in JavaScript. JavaScript actually tends to be usually a bit more functional. If you are used to link, it's also often how you write in JavaScript. You use maps or select, right? You use instead of where you use filter and so forth, but you use those functional expressions. So let me, in this particular case, I'm just going to do the for each loop for them. And for each fruit, I'm going to just do exactly the same thing. Now if I run it, I get what I expected. I get pears, oranges, and bananas. So here, actually for each fruit, the function is invoked separately, and it, of course, gets its own copy of the arguments, right? That's why they're captured separately for every one of those functions that I store there. And really, the right way of writing, well, I guess the shorter way of writing that in TypeScript or JavaScript is to just use a map. So instead of saying for each and adding it imperatively to the list of callbacks, you can just for every fruit just create an expression. Let me leave it like that. And then we can run it. And it also works, right? So here I'm using the map function, which is like select in link, right? So it essentially invokes the function for every element of the list and returns you the result. I mean, it returns you the list of results. Okay. And how much time? About that for each loops, JavaScript also has this for loop. So you would expect, for example, that thing to work, right? For every fruit, just print the fruit. No. It iterates over indexes of the array. So this is one reason not to use it. The other reason not to use it is if someone or you happen to override some methods on the array, happens to add some methods to the prototype of the array, then when we run that thing, then in addition to getting the indexes of the array, we are also getting those methods. So the message here, let me just close all that. The message here, do not use this loop. Just use the for each method on the array. Okay. So this is, well, so what I want to take out of here is that TypeScript makes for a much smoother migration from a statically typed language into this JavaScript world. So, each of us in the team, so I started doing that, but then a lot of other people, so well, like 4 other people came to the team and they started hacking on the code, and they didn't have much of the or at all previous JavaScript experience. They didn't just destroy the code base. The reason for that is because we had this familiar structure of the classes and so forth, and we had static type checking. So it really smoothens the transition to from C# to JavaScript. It actually avoids quite a bit of runtime errors, even though there are no 100% guarantees about the type safety of your program. Quite often, most of the time, the type system is actually strong enough to figure out the most common errors, like swapping the parameters, having typos in property names, and so forth. This is at least my experience with it. IntelliSense is useful, especially if you are coming later to the project, right? So those other people that came later, they actually could. IntelliSense is really useful to explore what's in the project. So that's really good. And finally, the code that you write in TypeScript usually tends to be a bit more functional in style than in C#, but this is really a matter of personal preference. But it lets you do that, and in some sense encourages that. So what we ended up with, well, we started with that WP7 app. We ended up with somewhat smaller TypeScript code base. This isn't exactly apples to apples comparisons. There are things that are still missing in that web app that were there in the phone app. And also this is a rewrite, so we kind of had a better idea how to write that thing. But it gives you some idea. There is quite a bit of CSS there that gives the entire visual appearance to it. The HTML count probably deserves some explanation. This is actually how we usually do those things. You don't really write those huge HTML files. You just have like a small HTML files to load the whole thing. And then you create HTML trees in the JavaScript. It's not, you don't really have this XAML. There are parts of the XAML that sit in CSS, but there are also parts that sit in TypeScript or JavaScript. So this is how we usually do it. OK, so now I'm going to show you a demo. There we go. Oh. So, oh. Let's see. Oh, OK. So this is a touch device. Isn't exactly a surface, but you get the idea. So this is a web app, right? You just go to a web page, loads up. It actually works in various browsers. This is IE 10 in a Metro style. So let's just go and create a script. It is asking me for a name, and then I can just go ahead and create it. So this is what we start with. We start with a script that is going to just print hello world, right? So I can just run it, and it tells hello world. I can just go back. Then I can just go here, right? If I press on a statement, right, it shows me that keyboard that is specialized and has this IntelliSense thing here, right? So it shows me all the methods that are defined on the string. So I can, for example, make it lowercase and then post it to the wall, right? Hello world in lowercase. OK, the other thing that I can, for example, do, I can cut it, and then I can add a for loop, and then do it 10 times. And then I paste it here, right? Run it. Goes just fine. You notice that I'm not using the keyboard, right? This is all touch. So this is all great, but let's try something more interesting. So I'm going to create a little game. So I'm going to just go and create landscape board. So this is a game board, like which contains our physics engine, where you can add sprites, add forces to them. They are kind of going to move around and so forth. And it's landscape, right? I'm going to create that board, and then I can put it in a variable. Okay. Then I take that board, and now I want to create a sprite on it. So I'm looking for create method here, and maybe I have problem finding it here, so I can just go here and say I want to create an ellipse sprite. There we go. And I put that in a variable. I can take that sprite and say set its color to a random color. And then I take that board and display it on the screen, post to wall. Right? Run it. There is a ball in the middle. By default, we put it in the middle. OK. So now let's make it move. Well, I can just go ahead here and take this sprite, oh no, actually, let's take the board instead and set the gravity vector on the board. X and Y, right? So we want, say, 500 here. So this is 500 pixels per second squared. And now, the other thing that I need to do is I need to add an event that is going to be run on every frame. And then, well, here I want to access the board, right? But the board was a local variable here, so what I can do, I can just go here and put it in a global variable. So I just press one button, right? And it promotes it to a global variable, adds a global variable here. I can just go here and now take that board, and I want to call the evolve method on it that's going to update the physics engine. And then I'm going to display the results of that update to the screen. Right? So now I run it. It's gone. To go back. Now, well, to make it a bit more exciting, we take that board and say, I want to create a boundary around the board. And now it's bouncing. Okay. Now, so this was all touch, right? But now it is, it is Windows 8 world, and it's also supposed to work with keyboard. So let me try to do something on the keyboard now. So I just go here, I take this sprite, right, and maybe, maybe I just mark 2 lines. And I cut that from here, and I add a new event, and I want swipe event. I go here, and here I can just paste it, Control V, works just fine. And okay, so let's make it a bit more exciting. I can take the sprite, and I can set its speed. Woo! That's no good. Where is that cable? Okay. Just reload the page. There we go. But it's still here. So it actually saved it. Nothing happened. Nothing bad happens. Actually saving it all the time. So I want to set its speed to delta x and delta y. So here, and then I want to set its position to x and y. And yeah, that should be it. Just run it. Oh, you could hardly see it. You get the idea. Right? It gets the speed from the swipe and the position from the end position of the swipe. So, but really what I wanted to show you is that you can edit it both with touch and with the keyboard as well, and on the phone. So this, if that network connection works, it actually should sync here, and I can edit it on the phone and run it there. Okay. So okay. So to conclude, if you are trying to write a big applications in JavaScript, TypeScript is going to help you. Types are good for you. Should use them. And maybe you also like TouchDevelop a bit. Yes? Oh, yeah, I just repeated. Yeah. So the question was, is TouchDevelop an entirely client-side app? Well, you can use it offline, except for the little bug that was there. But you can normally use it offline. It just syncs everything into your device. What it was trying to do there, it was trying to connect to the server to run code synthesis. But that doesn't matter. It doesn't really have to do that. Normally, you can just program completely offline. It does have a cloud component. So if you want to, for example, sync your scripts between devices, then obviously you need to use the cloud. If you want to publish your script so that others can see it, or install the scripts from our cloud server, then obviously you need to use the cloud. But it's the entire development experience is completely client-side.
So did you use the HTML web cache manifest? Is that what it is?
Yeah, yeah, yeah.
Okay.
Yeah.
Thanks.
Yes?
So you talked about kind of the quantity of code you ended up with when you moved from C# to
Mm-hmm.
do you have any kind of qualitative judgments? What was TypeScript like for the developers as compared to C#? What
Okay.
was TypeScript like for the developers as compared to JavaScript? Did it make
Mm-hmm.
them happier or less happy?
So the question was to compare the development experience in C# and JavaScript and TypeScript, all three ways. So TypeScript is in the developer preview right now. So I mean, it's not really, so for example, the IntelliSense experience is not really as great as it is in C#. However, compared to JavaScript, I actually, when I started doing that, I tried to write that I started writing code in JavaScript itself. And then I really quickly hit the limits. Because, the first thing I needed to do is to write a parser, a type checker, and everything like that in JavaScript. And I really quickly hit I really couldn't manage that thing anymore. So really, the TypeScript is, in that sense, a huge improvement, at least in my perception, and everyone else in the TouchDevelop team compared to JavaScript. Compared to C#, it's a different experience. So some things are easier, some things are harder. This immediate feedback, for example, is really nice. That the fact that you can just reload the page and it's there for you. No need to recompile and so. Well, actually, TypeScript you need to compile, but it's usually fairly quick. There's no need to deploy it somewhere or things like that. So this part is nice. But for example, there is no designer, right? So there are different trade-offs. Yes.
So you mentioned early on that with the phone app, there were certain things you could do with local data on the phone, and that was a way to make it more exciting for people learning programming. So I was wondering, with the web client, is that meant to sort of be an emulator of a phone environment? Like if I'm syncing a script between the web and the phone, and I'm accessing my music library, what have you, I guess I'm wondering how that would work on the web, and whether you can publish final products that don't run on the phone.
So yes, I mean, of course, the web browser is not going to give you access to your media library. It actually does give you access to quite a few other things, like, for example, the accelerometer, depending on the browser, the camera, and so forth. So you can still do some things. If you want to, for example, so we have a method like pick picture from library, right? This really maps kind of quite well to JavaScript. You just present the user with the dialog where they just pick the picture from somewhere. You can do those things. So some things you can do, some things you cannot do. So I mean, you cannot make phone calls. You cannot. So for that, if what you want to do is to produce Windows 8 app, you can actually do that. Actually those APIs are available. You can write that script on the phone and press a button, and we send you a solution. We should really send you a packet, but you just hit compile and run that. So you can access some of that, some of it in that way.
Got it.
But for the web only experience, right now there is all that gaming thing. And then we are also working on cloud data, where you will be able to write web apps that actually communicate with each other, have like more rich UI and so forth. So this would be an environment where you can really create web apps really easily.
Cool. Thank you.
Yeah.
The TypeScript editor that you were using, was that also JavaScript?
This is also pure JavaScript. You just go to typescript.lang.org/playground. Just click on playground. It's there.
That's all JavaScript.
It's all TypeScript compiled to JavaScript. Yes.
What's the debugging experience like?
Yeah. Very good question. I forgot to talk about that. You debug the JavaScript. You don't debug the TypeScript at the moment. They don't have yet debugger support. However, as you could see, the TypeScript and JavaScript, they are quite similar. They are quite easy to map one to the other. Especially if you are the one who have written the code. And so you actually just use the JavaScript debugger that comes with the browser. There is actually a good side to it. So for example, if something doesn't work in one particular browser, you can use the debugger in that particular browser to debug it. So that's the good part of it. It's not so bad. I mean, it's quite quite okay experience.
And one more question. You said you developed this in TypeScript, the editor that is on the TypeScript site. What other things does Microsoft use TypeScript to develop?
So the question is what other groups use TypeScript. I'm not 100% sure. I think some parts of Bing, some team in Bing. There is something called FuseLab, which is about social experiences. I think they have some web apps written in TypeScript. It's not too much yet because it's in preview. I mean, it's developer preview. We actually went through quite a number of iterations of the language where we had to update our code base. Right now, it's much more stable, but it was quite evolving. We were one of the early adopters there. Yes?
So why is the TypeScript version shorter? Is it because you're using like a val, or is it because it's your second go at the problem?
So the question is about the code size. Why is the TypeScript version shorter? Well, probably, I mean, I think there is a couple of reasons. One is that it is a rewrite, so we actually knew better. I mean, there were probably some parts that we just left off that weren't really all that needed. Some parts are really missing. So but then I guess also if functional programs tend to be shorter. If you write in more functional style, it tends to be slightly less verbose. In my experience, I don't want to get into any holy words about languages here, but it tends to be a bit shorter. If it's easier to understand, that's a different question. So yeah.
Are those real line of codes or text count?
So I didn't understand.
Are those real line of codes? They don't have to do anything with spacing or special characters. So when you compare 150 versus 47,
those are okay. So those are just lines of code in the text, even including comments. So which aren't that many, but anyway. But those are just lines of text. We didn't do any other comparison. But it's not really that that in one you do like longer lines or anything. It's pretty comparable in that sense, right? And yeah. Yes. Yeah.
I wonder why you didn't use script chat.
So TypeScript really gives you this full web experience. I mean, really, you can. Well, I guess ScriptSharp also gives you that to some extent. But in TypeScript, it's really a thin layer on top of JavaScript, right? So you're really writing for the usual way that JavaScript programs are written. In ScriptSharp, it's really a full, I mean, the compilation is quite a bit more involved and so forth. So it's further away from the underlying platform. And so I guess that's the reason. Yes, I think that's some, okay. Yeah?
Do you have something like a generic type of array, 64-bit type of function?
There are such types. So the question was about the different sizes of arrays and so forth. There are such types in JavaScript. We didn't really use them.
No, TypeScript.
In TypeScript, well, right now there are no generics in TypeScript. They are working on it. Yes?
Yeah. This may seem like an obvious question, but if you have little experience with the real tough stuff in JavaScript, would using TypeScript really act as a kind of a bridge to learn more about JavaScript? So if you're really familiar with high-level C++, C# type programming, then providing a solution to your problem and then seeing what the JavaScript is, essentially you learn how to do it in JavaScript. Or do you really have to know a lot about the intricacies of JavaScript to use TypeScript effectively?
So the question is, can TypeScript be a sort of a bridge for... Oh, no, sorry. You were on the mic. I don't have to repeat. Yes, it can actually help with that. You don't really have to know a lot about JavaScript. You need to know a few things, like about these pointers, the things I've shown you. But this is just a few things. You don't really need to know all that much about JavaScript. And that was the case for everyone in our team, right? They didn't really have much much experience. Can you then write straight JavaScript? I guess you can. I mean, isn't it, you would probably learn how that mapping works. Yeah. Yeah. Mm-hmm. Yes.
Yeah. How did the size of the generated JavaScript compare to the size of the TypeScript?
This is a good question. It's almost 1-to-1. I mean, essentially, you've probably seen, right? I mean, the code sizes on both sides, and they look pretty similar. The compilation model of TypeScript is essentially type erasure, so it removes the type annotations and expands the definition of classes into something slightly different, but of similar size. So it's very similar size. Yes?
Can you export the script from TouchDevelop?
Yes. So, that's probably one thing that I didn't say. So it syncs between all your devices. So I write a script here, I can continue there.
So can I export to JavaScript?
You can export to JavaScript from the web. You can export to Windows Phone 7 apps from the phone.
Right, when you open it up, right?
Mm-hmm. Yes? No, we did not use any libraries other than the DOM. I mean, what comes with the browser. We didn't use jQuery. Okay. Thank you.